So hi everyone. So here we are going to see the third video for chapter 2, physical quantities and measurement for class 8 physics for St. Thomas School, Ranchi. So here we are going to see the next topic as application of relative density for floating and sinking. This topic means that with respect to relative density of an object, we can able to determine that whether an object can able to float or sink in any liquid or water. So the relative density of a substance gives us an idea whether a substance will sink or float in water. So if the relative density of a substance is less than 1, it is lighter than water and hence it will float in water. And if the relative density of substance is more than 1, it is heavier than water and hence it will sink in water. Thus, with the help of relative density, we can determine that whether that object is going to float or sink in water. Next topic we are going to see as law of flotation. So under this law of flotation, we are going to determine we are going to find out the reason why any object floats or sinks inside the water. So what this law states here that when any object immersed inside water, then the amount of water which is going to get displaced by it, if that displaced water is going to be equal to weight of that object, then it is going to float. And in this case many other situation happens that we are going to see further in this video. So once again, the law of flotation. So according to law of flotation states that when a body floats in liquid, the total weight of the body is equal to weight of liquid displaced by its immersed part. So this law is given by the scientist Archimedes, and this is the respective diagram that this object is immersed inside this liquid and the amount of water which is going to displace. When we are going to weight this water displaced, and if this weight of this water is going to be equal to weight of this object, then that object is going to float on the surface of water. This is law of flotation. Next we are going to see principle of flotation. So under this principle of flotation, we are going to see many different cases, as well as we are going to see that when an object emerges inside the water, what are the different forces going to act and how these forces are going to balance each other to float and sink on water. So here, when a body is immersed in a liquid, there are two forces that acts on it. So this is the diagram that in a tumbler filled with a water and this object is immersed inside. So in this case you are observing that two different forces acts on this object. One is the force acting upward, one is the force acting downward. So this upward force is given by the liquid on this object and this downward force is given by the object. So let's see the diagram more clearly. So this upward force is given by the liquid in upward direction and this downward force which is the weight of this object. So this is the two forces acts on the body when this object is immersed in any kind of liquid. One is the buoyant force acting upward and second is the weight because of this object which is acting downward. So first factor is weight of the body and second factor is buoyant force. Then now we are going to see three different situations which is going to arise when a body is immersed in a liquid. So under this topic we are going to see that what are the three different cases going to happen when any object is immersed inside the liquid. Three things happens possibly, that body can able to float, body can able to sink, or body can able to float just below the surface of that liquid. So first case. So in this first case we are going to see that if the buoyant force is less than the weight of the body, then the body sinks in a liquid as the resultant force acts on the body in downward direction. So this is how it is going to happen, that this object is going to sink inside this liquid when it is immersed in it. So why it sinks in a liquid? Because in this case weight of the body is more than the upthrust act on this object. Or we can also say that when the density of the object is more than the density of the water, then it is going to sink. Next we are going to see the case when buoyant force is equal to weight of the body, then body floats just below the liquid surface as resultant force acting on the body is 0. So this means that when this object is immersed inside this liquid, then what happens that the weight of this object is such that it is equal to upthrust acting on it. So in this case what is going to happen, this object floats just below the surface of this liquid. So or what we can say here, that if the density of the object is equal to density of the water, then this object floats just below the surface of water. So third case we are going to see here that when buoyant force is greater than weight of the body, then body floats partially above the liquid surface as resultant force acting on the body is in upward direction. So this is the diagram for this, a normal diagram that we know very well, that this is a wood, as we know that wood floats on water. So why wood floats on a water? Because the weight of the wood is less than upthrust acting on this object, thus it is going to float on it. Or what we can say, that density of an object is less than the density of the water, then it is going to float on the water surface. So these are the three different cases of floating we have seen. Next we are going to see some of the applications of floating. So first example is floating of iron ship. So we all know that a ship is made up of steel or iron material, and its density is much higher than the density of water, even though ship floats on a water. So why ship floats on water? Because overall when we are going to find out the density of the ship, then the density of the ship becomes less than upthrust, thus ship floats on water. Next application, floating of man. So in this case also, this man while swimming balance its body weight in such a way that its weight become less than buoyant force, then it is going to swim or float on the water. Third case, submarines. So in a case of submarines, as you all know, that submarines can very well able to float inside the water surface as well as above the water surface. How it happens that in this case it has to manage its overall weight. So this is the further diagram we can understand. So in this case, when submarines wants to move up above the water surface, then what is going to happen in this water tank inside this submarine, this in this water chamber, they will fill less amount of water and thus it can able to float on the surface. When slowly it is going to start increasing this water inside this water tank, then what is going to happen, the weight of the submarine is going to increase slowly, thus its density becomes more than the density of water afterward. And then when the density of the object becomes more than density of the water, then slowly it will start sinking inside the water, or it will start going in the water. And this is the third case. Then when the weight of this submarines become more than the upthrust, then it will sink. So this submarine is the very good example to understand that how an object can able to float or sink inside the water. Then the next example is about iceberg. So as we all know that iceberg floats. Why icebergs float? Because density of ice is less than density of water. Thus ice very well can able to float on the surface of water. So this is all different applications of floating and sinking. Thank you.